This section's main focus is on binomial distributions. So the first thing we're going to talk about is binomial probabilities. And with a binomial probability, you only have two possible outcomes, thus the beginning or prefix of bi. And those two possible outcomes are either it being a success or a failure. So for example, if you wanted to draw a red card, you would either draw a red card or you wouldn't. So it'd either succeed or fail. So there's two possible outcomes. So the probability of getting a success is the same for each trial. So it doesn't change. So it stays the same. And if you're trying to find the probability of a failure, you can use the whole idea of complement. It's 1 minus 1 being 100% or all of the outcomes, minus the probability of a success. So in this example, if I have the probability of succeeding being 2/3, probability of a success, then the probability of getting a failure is 1 minus 2/3, which would end up being a 1/3 chance. Now notice both of these two guys, they add up to all the possibilities, they add up to a 1. So you either succeed or you fail. So there's a formula that you're going to be using to calculate the number of successes for a binomial experiment or binomial probabilities. And here's what it is. So the probability of getting k successes out of a certain number of trials is equal to this formula, which looks pretty intimidating. So here's what everything represents, and I'll kind of go through what the formula is. So first, n is the number of trials. So for example, if you're drawing something 10 times, then n would be 10. That's the number of trials that you have. K is the number of successes. So for example, you're drawing 10 times and you want exactly 5 successes, K would be 5. So P is the probability of a success. So if it's like beans in a bag and you had 2/3 of them being red and a third not red, you'd have a 2/3 of a chance of drawing a red, which would be a success. So that would be the probability of success. And 1 minus P is equal to the probability of a failure. So you basically just take the complement of whatever the success is. So if you look at the formula, you'll have the P that's the success, and this right here is the probability of the failure. And then what you have is your number of trials here for n, and then this is all the number of successes you want. So if you have 10 trials and you want 5 successes, you'd have 5n for k each here and here, and this would be n minus k. So let's go ahead and do an example. So this would be an example of a binomial probability because you're taking a multiple choice quiz that has 5 questions and you have 4 answer choices for each question. And it says, what's the probability you'll get exactly 3 answers correct by guessing? So the reason why it's considered binomial is either you're going to get it correct or you're going to get it wrong. So there's only 2 outcomes that you can have. Alright, so what we have is we have 5 trials here because there's 5 questions that we're either going to get right or get wrong. So we would have for n right here 5 questions, and we want to randomly get, now order doesn't matter, that's why it's a combination. We want to get 3 answers correct, where we don't care about the order of those 3 answers, we just want 3. So our number of successes is going to be 3 because that's what we want correct. The probability of getting it correct, well remember there's 4 answer choices, so the probability of a success is you have a 1 out of 4 chance, because remember there was 4 answer choices, and you want it correct 3 times. There's a 3 out of 4 chance, because remember the 1 minus P is the failure, and this is going to be twice, because remember there's 5 trials, and that means if you're getting it correct 3 times, then you would have to get it incorrect twice. Notice what these add up to. They always add up to the total number of trials that you have. So I just wanted to point that out. So then all you have to do is you can just type this into your calculator and you'll end up getting 5c3, which is 10, and then you get 1/4 cubed times 3/4 squared, which would be 9/16. And so multiplying that out, you end up getting a 0.0879. So you have about an 9% chance of actually getting 3 correct by guessing. So the next thing we're going to be doing is making a binomial distribution histogram from our binomial probabilities. So here's the steps. So actually before I give you the steps, just so you know, a histogram is a bar graph. So you're basically looking at, you want to make a bar graph from your binomial probabilities. So you're going to be making a graph that looks something like that. So the first step is to make a table for k successes with their probabilities. And that table will look something like this, where k represents the number of successes and the p of k represents the probability of k successes. So what you're going to do is you're going to start off with getting no successes, 1 success, 2 successes, all the way up to the number of trials that you have. So if there's 10 questions or if there's 10 drawings, up to the number of trials. And the second and last step is to actually graph your results. So when you make your histogram, what you're going to have on the x-axis is the number of successes. And so you're going to go ahead and scale that, starting with getting no successes, getting 1 success, getting 2 successes, 3 successes, and so on. And then you are going to have the probability on the y-axis. And your probability is going to be anywhere between 0 and 1. So you'll be basically making your bar graph extending to some value up to 1. So what we're going to do for this second example is draw a histogram of the binomial distribution for the multiple choice quiz, that problem that we just encountered. So we're going to start off by making our table. So remember, k represents a success, and a success in this example was the number of correct questions. So we're going to start, if you remember, it was a 5-question quiz. We're going to start off by calculating if you get none right, so 0 successes, 1, 2, 3, 4, and getting all questions correct by randomly guessing. So now we need to calculate those, and we already did getting 3 correct. So if you remember, there were 5 total questions. We wanted to randomly choose 3. And the probability of getting a success was 1 out of 4. We wanted it 3 times. The probability of getting a failure is 3/4, and we wanted it twice to get a total of 5. And so we ended up calculating before that this was 0.0879. So we're going to go ahead and calculate it for 0 successes, 1 success, and so on. So this would be 5 questions, getting none right, so choose 0. Probability of getting it right is 1/4. We want it no times. And 3/4, we want it all 5 times. So plugging that into your calculator, you get 0.0237. To get 1 success, you would have 5C1. So you want 1 correct. Don't care about the order. You want it correct 1 time. That means incorrect would be 4 times. So when you go ahead and calculate that, it would be 0.396. Then you do the same. So this would be 5C2 times 1/4 squared times 3/4. And if we get it right twice, that means we have to get it wrong. We have to get 3 wrong. So this would end up being 0.264. Now I'm not going to write out the rest. Actually, I will. I'm just not going to take the time to write it on the screen. And then what I have is a binomial distribution for all possibilities. These are all of my possibilities right here. So if I were to add them all up, they should add up to 1. So I'm going to make that note here, because if these are all the possible outcomes, they should always add up to 100% or 1. So on the x-axis, I'm going to put on our k's, which is our number of correct questions. And on our y-axis, this is going to have to, I'm going to have to determine my scale from my probabilities. Because remember, the y-axis is the probability of that event happening. So looks like I'm going to go by 0.1s. And I did that because the largest I really have to go to is about 0.4, which is right there. So then I'm just going to draw my histogram or my bar graph. So at 0, I get about 0.237, so I would go up 0.25 is halfway, so it would be something about right here. And again, this is just an estimate, so that's the first one. The second one, getting 1 success or 1 question right, is really close to 0.4, so I'm going to get as close to it as I can. And I would get this for the second bar graph, or the binomial distribution. So then I graphed getting 2 successes, 3 successes or 3 questions correct, 4 successes, and last but not least, which is really close to 0, 5 successes or getting all 5 questions correct by randomly guessing. So this is called the binomial distribution. All of these bar graphs, if you were to add them all together, would add up to the 1 because it represents all of the possibilities you could have. So in this next question, I want you to tell me what the probability is that you get at least 2. So at least means 2 or more. So if you look back at the diagram or the table that we did here, 2 or more would be all of these guys right here. That's at least 2. So I'm going to add all those together. So when I add all those together, I get about 0.367 if I don't round. And that would be the probability of getting 2 or more correct. Another way you could have done this, so at least 2 is the same thing as if you did the complement of 1 minus the probability, and the opposite or the complement of at least 2 would be getting 0 or 1 correct. So I could go back to the table and I could do 1 minus these two guys. See how they're not included? Because remember, these all add up to 1. So that's another way you could do it. And if you notice, if I take the complement and subtract it from 1, then you'll notice that I'll get the same thing as well. So it's just 2 ways of doing the same thing if you didn't want to have to calculate all those other values.